let's go ahead and look at these patterns that hopefully you guys sort of came up with here. You know, when we went through all of those foiling problems. Okay, the first one that hopefully we came up with, and maybe it's the easier of the two, is the sum and the difference pattern. So the sum and the difference pattern says, you know, the first terms of the binomial match. Okay, so you have a and a, and then the second term of each binomial match. All right, but we have these different signs. We have the plus in the first grouping and the minus in the second grouping. And when we FOIL those, the result ends up being just this a squared minus b squared thing here. Okay, so the example of this would be this. So if we have 3x and 3x here, okay, those you can call those the a terms, or they're just the first terms of the binomial. Okay, we have the b, we have a 4 and a 4, and then we have that same pattern, right? We have the minus and the plus. Okay, and so if we were to FOIL this, the first times first, I'll do this one in green, that would give us 9x squared. Okay, and we should have noticed, you know, hopefully in that video, that the outsides here, if we take outside times outside, that'll give us a positive 12x, and inside times inside would give us a negative 12x. Well, those two numbers are opposites, so when we add those, they just cancel out. All right, and then finally, the last times the last year will just give us this negative 16. So you notice that red stuff there is just going to drop out when we add them together, and this is going to be our final answer. Okay. The square of a binomial pattern is a little bit different, okay? What we have to notice here is we still have these matching a terms and b terms, right? So really, if we want to just get rid of this exponent here, really this is just a plus b times a plus b, and those a terms match and the b terms match, but the signs are the same now. We have plus and plus. And so the phenomena that we actually see here is that it's kind of similar to the first pattern, except we have this plus 2ab in the middle now. Okay, so 2 times whatever a is times whatever b is, and that's what our term is going to be. Okay, and so here's a numerical example that kind of matches up with that particular pattern. If we were to FOIL that up, it's going to happen every single time. Okay, now again, this part's a little bit different with I guess with subtraction, okay, the only way it's really different, I'm just going to rewrite this as a minus b times a minus b. We can also refer to that as a minus b squared, okay, but if we were to FOIL this, instead of getting the plus 2ab in the middle this time, we get the minus 2ab. And so our example, our numerical example, is just going to look slightly different this time with the plus minus plus pattern. Okay, now if we look down, I keep telling you guys that we have area applications here with what we're studying right now. Okay, and this says the area model shown at the right gives a geometric representation of the square of a binomial pattern. Okay, which is the one we went over up top there. We have a plus b squared, and these are all the parts. Okay, so let's just look at this in a really small sense. So if I have b and b here for this little square. Okay, so b times b is b squared, right? So that's going to give us the area of this little guy here. Okay, now if I want the area of these kind of rectangles that say AB in them, okay, well I'm going to get that from multiplying this A times, well, if this is B, that means this is B as well. Okay, so B times A or A times B is going to give you AB, and it's going to be the exact same thing over here. So this is our A, kind of looks like a 2 there, sorry, and this is our width of B, okay, and that's going to also give us this AB. So that's where the 2AB comes from. So look at this 2AB, and it's like these two little rectangles here, okay? And then finally the A squared, okay, comes from, well, if this width is A, that means this is A, okay? And if this one's A, that means this is A. And so this is kind of where our A squared comes from. So we have these three separate parts here, the green, the red, and the blue. And that's kind of really sort of models this square of a binomial pattern. Okay, I think it does a pretty good job of that. All right, so we're going to take a look at some examples here in the next videos. And hopefully this starts making a little bit more sense.